Hi students, welcome back to Chapter 2 of BCA 1, otherwise known as BCP 150S. Today we're going to be covering computers, the machines behind computing. So we will be basically looking at what is a computer, what is it comprised of, what is it made up of. I will be quite quick today. The video will be no longer than 15 minutes, as I understand you all need to save on bandwidth. Please be aware you need the textbook, MIS9. There is a lesson in the link in the first week where one can purchase it online. Anyhow, let's begin without further ado. Define a computer system and describe its components. It's basically a machine that will accept data or information as an input. It will process the data without human intervention using stored instructions, and it outputs information. So, correction here. Data is unsorted and information is sorted. So please bear that in mind, that data is something that is known as raw. If I say to you the word 10, we don't know whether it is 10 Rand or the street number 10 or 10 of anything. That is known as data. It is unsorted. The computer will sort it for you into information, and information can, for example, be 10 Rand or 10 number such and such street, and so on. Discussing the history of computer hardware and software. These are classified into generations, and there are 5 generations of computers. The first generation, we're moving now right back into the 1940s and 1950s, which is a long time ago, uses vacuum tubes. I would like you guys to Google these and have a look at them. They're very interesting to look at. The second generation of computers used transistors. They were a bit smaller, but the early generation that used vacuum tubes could fill a room or several rooms just for something the power of a PC. Transistors, they managed to make them a lot smaller. Then we have our third generation using integrated circuits. Integrated circuits is many transistors packaged into a single package. These days we're using something called very large scale integration, or VLSI, which is what you will find in your cell phone. They have taken millions and millions of transistors and they've placed them on a tiny little integrated circuit, which then will go into your smartphone. So effectively what they have done is we are going smaller and smaller and smaller and smaller inside as the generations of computers proceed. The 5th generation that we are using today uses parallel processing. You may have heard of cloud computing, which is very popular today. And you get cloud computing, which is many CPUs used together, which is even beyond parallel processing, and your computer sits on what they call the cloud. So it is virtual computing. So 5th generation will include either a whole lot of computers in a room using parallel processing of many CPUs together, or 5th generation will also include cloud computing, which is virtual computing that we use online. So you no longer have to have a physical computer. You can go and purchase the use of a cloud computer, which is a big cluster of computers online. I'm going to deal with the terms, some basic terms that we use around computers. They are made up of buses, which are links between the different parts of the computer. They can be parallel, which is 8 bits next to each other, or serial, which is 1, 0, or 1 at a time. They can be internal, which is inside the case, or they can be external, which can go to your printer, for example. A disk drive is called a peripheral. A peripheral is anything that you plug into a computer, and it basically records, stores, and retrieves information. Typically known as a hard disk drive. These days we have solid state ones, which is called an SSD. The CPU, which is the heart of the computer, is also known as the CPU case is also known as the computer chassis or tower. So that tower is not called the CPU, it is called the CPU case. It is the enclosure containing all the components that are inside the computer. The motherboard is a main circuit board that contains the connectors that you will get coming out of the back of the computer and the front of the computer. It will contain the various parts of the computer, such as the CPU, basic input-output system, otherwise known as BIOS. The BIOS is what starts up a computer when you switch on the power button. It checks that everything is there, that your CPU is there, that your memory is there, that the hard drive is functional, and the BIOS will then do what they call bootstrapping and start up the computer. We have memory, storage, interfaces such as USB, serial and parallel ports on the back. When they are speaking of serial and parallel, they are speaking of serial is noughts and ones in a row, and parallel could be 8 noughts and ones in groups next to each other. Expansion slots where you may plug in some things like a sound card if you don't have, and controllers for standard peripheral devices. Peripherals are whatever you will plug into the computer, such as the monitor, disk drive, keyboard. If we have a look at the factors distinguishing the power of computers, why is a computer such a powerful device? It is much faster than humans. It is accurate. It does not make mistakes. And if we look at storage and retrieval, we can store huge amounts of data. And we can locate that item in a fraction of a second. And that is what makes the power of computers as opposed to humans better. Some interesting information, and I'm sure many of you have heard of this. If we're looking at our zeros and our ones, so a bit is known as a single value of 0 or 1, and that is basically at machine language where a computer will understand only zeros or ones or groups of zeros or ones in order to function, and they do so till this day. 8 bits, which is parallel, is called a byte or a character, and then as the powers of them move up, you will recognize some terms that are commonly used today. Kilobyte, megabyte, gigabyte. These days you can buy a terabyte or more hard drive. What's coming in the future, or many terabyte hard drives put together in a group, is known as a petabyte, and then exabytes. Things like Google will typically be storing exabytes or more of data. Looking at computer operations that can perform 3 basic tasks. Logical, such as arithmetic, storage of data on the hard disk drive, and retrieval of that data on the hard disk drive. You will not need to be able to explain the logical operations or the storage or the retrieval. Just be aware that these are the 3 basic tasks that a computer operation is made up of. Not everything else is performed. Note, everything else is performed using 1 or 3 of the above, so it can be 1 or all 3 together when you are utilizing a computer. Then we have the types. Now we are looking at the components of a computer here. Discuss the types of input, output, and memory devices. Okay, I will go through this relatively slowly because there are some new terms here for you. The main memory, which is known as the hard drive, stores the data and information. This is known as the hard drive, stores data and information, and it's volatile. The volatile word means it can be written and erased. It's not there forever, such as, for example, if you write a CD or a CDR, your information is there permanently, and if you want to change it, you would have to throw that away and write a new CD. Generally, also included in here is something called RAM. When the electrical power is turned off, if you are working in the middle of an assignment, all of that information will disappear. And I'm sure we know with load shedding that has happened to you. You were working on something, the power went off, when the computer came back on, your work was lost. So this stands for random access memory, and it is actually powered by electricity. Secondary memory, which is non-volatile. I'm making a correction on the first one. Non-volatile will hold information when the computer is off. And this will include things such as your hard disk drive and a CD writable. So I made a small mistake here. When we speak of the main memory, we are speaking only of RAM. When we speak of secondary memory, we are speaking of things such as a hard disk drive, a CD-ROM, a flash drive, and so on. Random access memory. I'm sure we've all heard of the term RAM when we use a computer, and the more RAM that you have in the computer, the faster or better it is for the computer. Why is this? You can think of RAM as the size of a desktop. The bigger that your desk is, the more documents you can put on it. It is also volatile memory, which means it will disappear if the electricity turns off. Data can be read and written from it to it. It's also called read-write memory. And please be aware, I think the main point about this is that the more you have, the more you can work with, and that it is volatile. We have something called cache RAM. Cache is a new word for you guys, and it resides on the CPU. It assists the CPU to access data quickly and transfer data in and out of memory. So please be aware that is part of the CPU, or it will sit beside the CPU, and it is helped to speed up the computer. Read-only memory, ROM, known as non-volatile. So we have spoken of volatile memory already. Non-volatile, the data cannot be written to read-only memory. We have magnetic disks made of mylar or metal, used for random access processing. To simplify this, you can have magnetic tape, which we used to use in the past. These days we use CD rewritables and so on. CD-ROM, write once, read many, in case that is confusing you, and DVDs. Those are regarded as ROM, and that is the type of memory that you can write once to it, and you would need to typically throw away afterwards, as you cannot rewrite to it. Sometimes to make computers more reliable, and here is a new word for you called redundant. Redundant is another word for reliable, and let me put that in here. It's a reliable or redundant array of independent disks, and it's called RAID. It's a collection of disk drives used for fault tolerance. That is another word for reliable and improved performance, typically found in large network systems, online storage, large servers, virtual servers, servers hosted by third parties. And you can buy RAID storage space. The nice thing about this is one hard drive, if you have 10 hard drives inside a computer and one of them fails, some types of RAID, such as RAID level 5, you just take out the broken hard drive, you put in a new hard drive, and it will rebuild that information from the extra additional information stored on the remaining hard drives. In that way, you can never lose your data. We have large networks these days, of which one of them is known as a storage area network. It's a dedicated high-speed network consisting of both hardware and software, and it is shared amongst storage devices. So you will have boxes full of hard drives using a piece of software. It's called a disk array. And CPUT actually uses this to store all of your information. And it's actually called a storage area network. I'm moving on to the classifications of computers. Very straightforward. Nothing additional here that you would need to worry about except the basic learning of what they are. How do we classify a computer? Via cost. It can move anywhere from very cheap for a small PC to extremely expensive for a supercomputer. How do we classify them? Cost, amount of memory, how fast they are, how sophisticated they are. I'm talking between a cell phone or PC or supercomputer. The types of computers are sub-notebooks. That could be a cell phone, a notebook, which could be a tablet, a PC, a mini computer, which could be a small server, a mainframe, which is a large server which serves many to what we call terminals or dumb terminals. Mainframes generally will reside remote from where you are working, and it will send the information over the network. And then finally we have our supercomputers, and the one that is referred to in the book is something called IBM Watson. Please Google IBM Watson. I will write it down for you. Whoops. I've written it down for you. IBM Watson, please Google this. There are many YouTube videos on IBM Watson, and you will be asked a question on what is IBM Watson. IBM Watson is a supercomputer that companies are using to process information to gain competitive advantage. So they are using it basically for marketing. Describe the two major types of software. So we have spoken already now about the hardware, which is the physical devices inside the case that we can touch, such as the hard disk drive and the RAM and the ROM. We're now moving on to software, which is what controls the computer. We have application software, such as Microsoft Office, software developed or in-house inside a company, used to perform a variety of tasks. One that we're going to be using in this course is Microsoft Access, and we will start that during term 2. An operating system, and I think you've all seen it, is a set of programs for controlling and managing the computer hardware. To keep this simple, on your smartphone you will be running Linux, or if you have an Apple phone, it will be running something called iOS. Or if you have a PC or a laptop, it will typically be running Linux or Windows. And an operating system is a large set of programming code that assists all of the components inside the computer to work together and obviously share the resources. If we move on to computing languages, they are listed by generation. I would like you to please be aware there's 1GL, 2GL, 3GL, 4GL, and 5GL. And these are the generations of computer languages. I've already mentioned that computers work in zeros and ones. Machine language, the first generation of computer languages, going right back to the 1950s, the 1940s even, consist of a series of zeros and ones that represent data or instructions to the CPU and the computer. It is dependent on the machine, and it will only run on one computer, and it is known as a first generation language known as machine language, and it is to this day the basic language that your computer will operate on. Then we have assembly language. There is one called assembler, that is used to program microcontrollers. It is the second generation. It is a higher level language. In other words, easier to use than machine language, but it is also machine dependent. So it will be written for a specific computer, and it uses a series of short codes or mnemonics to represent data or instructions. So we could just tell it read something into memory or take something out of memory. High-level languages, 3GLs, are machine independent. And an example of this would be, for example, Java, C++, many languages. There's one that you're going to learn called Visual Basic, are part of the third generation of computer languages, and each one is designed for a specific purpose. Depending on which language you learn, you'll be able to produce your apps in your high-level languages, your 3GLs. Your fourth generation languages use things like objects or an interface where we can use very powerful commands. They're easy to learn, and you will just tell the computer, please print something. End of story when you are actually writing the program language. And even for people with little computer training, they are easy to use because they are far closer to the English language. The fifth generation languages include artificial intelligence. Now we are in today's technology, such as knowledge-based systems. Sometimes when you fill out a form, you're actually interacting with artificial intelligence. There are several computers out there that you can Google, that you can actually go to the internet and ask questions of, and the computer will answer you using artificial intelligence. Visual programming. It is watching what you are doing, and it can understand and learn from that. An example of that can be facial recognition. And it also uses a graphical approach. These are designed, and we are hoping for the future that they facilitate natural conversations between you and the computer, where you will be able to write computer code just by simply speaking to it. If we have a look at the review, discussion and questions, these are for the students, but basically you can go back through the notes and the textbooks. What is a CPU? That was question 1. How are the fourth generation of computers identified? Well, there we have, they use macro codes that can take the place of several lines of programming. There we go. There is the answer to that one. Computers draw their power from 3 factors. Again, it's in the note. I'm not going to waste time on these. They are speaking about organic light emitting diodes. The screens that you generally look at are called LCD screens. There is a new generation of screens called organic light emitting diodes, and these are typically foldable. They are brighter, and they are the future of the displays that we are going to see. So maybe not now, but maybe 2025 you will be able to buy a foldable cell phone, which would be pretty cool. What is a redundant array of interdependent disks? We have covered that. What are 3 examples of server platforms? I haven't covered all 3, but I will give you an example. We will have Microsoft Windows, we will have Linux, and you will have dedicated programs such as those written by IBM. What is an operating system? That is covered above in the questions. What is one example of an operating system for PCs? That could be Microsoft Windows, and an operating system for mainframe computers could be Linux. That is as far as I'm going to go today. You guys are welcome to ask questions on our WhatsApp groups, and you are welcome to email questions as well. We will answer questions anytime during the day of the lesson and on the weekends when we are free. Thank you for attending this lesson, and thanks so much, guys. I hope you have a wonderful day.